Today you are watching AliAziz YouTube channel.
AIAG and VDA FMEA. For fresh and experienced candidates. AliAzizQualityEducation Quality Education channel providing you the job best interview related videos, so don't forget the subscription button. Introduction to AIAG and VDA FMEA methodology. These are interesting times in the world of FMEA methodology, new product and process introduction. Failure modes and effects analysis has been around for several decades, initially utilized primarily in the automotive manufacturing sector. FMEA methodology has since spread into countless other industries, including the heavy equipment, aviation, recreational vehicle, medical equipment, and agricultural equipment industries, to name but a few. Traditionally, the most comprehensive and informative source for information regarding the implementation and use of FMEA practices has been the AIAG Potential Failure Mode and Effects Manuals. While the manuals were very effective within the U.S. market, some suppliers to offshore automotive manufacturers had a difficult time adhering to their customers' requirements regarding FMEA. Well, there is a new sheriff in town, so to speak, packed full of new and interesting information and changes aimed at establishing a more universal FMEA methodology that can be used by manufacturers around the globe. What is AIAG and VDA FMEA methodology? The AIAG and VDA FMEA manual is not a revision of the previous AIAG FMEA handbook. This manual is the product of a collaborative effort between automotive manufacturers, Tier 1 suppliers along with members of AIAG, Automotive Industry Group, and the VDA, Verband der Automobilindustrie, which is the German Association for Automotive Manufacturers. The AIAG and VDA manual is intended as a replacement for both the AIAG 4th edition FMEA handbook and the VDA Product and Process FMEA Volume 4 manual. While the manual has technically been completely rewritten, there are several aspects that are familiar and tools that we have been using for years prior to this publication. However, there are some significant segments of the FMEA process that have been modified. Some of the key differences include an increased push for prevention controls over detection. In addition, the FMEA process has been transformed into a 7-step system that integrates the robustness tools that many FMEA facilitators utilize today into the FMEA standard process. In addition, the RPN has been eliminated and replaced by an action priority process that includes a set of tables used to define a priority for action to reduce risk regardless of the number of actions identified in the FMEA process. Furthermore, the AIAG and VDA FMEA manual has opened up a whole new area of risk analysis through the inclusion of a supplemental method for monitoring and system response. This new methodology enables practitioners to analyze diagnostic, detection and fault mitigation during operation of the vehicle or machine by the end user. While these changes are significant and appear daunting to a small portion of practitioners, the new methodology clearly offers an opportunity for more effective FMEAs and opportunities for superior risk analysis and mitigation. Why implement AIAG and VDA FMEA methodology? Technology is advancing at an amazing rate. There have been tremendous advances in the technology incorporated into the vehicles, machinery, and equipment today. With all this new technology, there also comes an equal amount of technical risk. Therefore, it is even more important to identify, evaluate, analyze, and reduce any potential technical risks. This collaborative effort between AIAG and VDA has provided manufacturers with a more robust tool in their toolbox for doing just that. In addition, by utilizing a common standard supplier, each market can now utilize the same methodology, thereby clearing up any questions regarding FMEA requirements. Therefore, the new AIAG and VDA methodology is not only a more comprehensive, prevention-centered process, it also provides a better method of action prioritization. The concept of RPN has been eliminated and replaced with an AP, action priority, system to prioritize recommended actions. This improved action prioritization process will enable your teams to clearly identify and focus on the actions that will have the most positive impact on your designs and processes. Furthermore, through the proper application of the supplemental FMEA for monitoring and system response, FMEA MSR, your organization will be able to mitigate risk resulting in a safer state of operation of your vehicles or equipment by the user and ensure adherence to all regulatory requirements. Yes, the new methodology will take time and effort to implement, but the advantages to your organization and your customers are well worth the investment. When to perform AIAG and VDA FMEA. The AIAG guideline and the new AIAG and VDA manual both list 3 cases for the application of the FMEA tools. However, the new manual goes into more detail describing the scope of each FMEA and also includes more detail in describing the third case for FMEA. The cases are as follows: new designs, new technology, or new process. The focus of the FMEA can be either new design, new technology, or new process centered. New application of an existing design or process. The FMEA activity should be focused on the impact or the new environment, location, or altered duty cycle on the existing design or process. Engineering changes to an existing design or process. The FMEA review is primarily focused on the change to the product design or process and what circumstances or event initiated the review. The AIAG and VDA manual goes into more detail than the previous standard in describing the various circumstances upon which a FMEA or FMEA review may be required. The manual indicates that the review can be initiated by design changes, process changes, product recalls, quality issues, non-compliance to regulatory requirements, functional requirement changes, or changes to either the hazard and risk assessment or threat analysis and risk assessment, and/or lessons learned. There are indeed many circumstances or events that may indicate the need to perform an FMEA exercise. How to apply AIAG and VDA FMEA methodology. There are 2 primary approaches in the application of FMEA. They are the design FMEA, which focuses the analysis on the product functions, and the process FMEA, which analyzes the steps in a process. This can be a manufacturing process, or an office of operational process as well. If you really think about it, most everything that you do can be described as a process. The AIAG and VDA FMEA manual includes information on both the design and process FMEAs, but also the FMEA MSR, which is described as a supplemental FMEA for monitoring and system response. There is too much information within the manual to cover here. Therefore, our primarily focus will be the FMEA structure and process along with a review of the new FMEA MSR methodology. The FMEA 7-step approach. The new AIAG and VDA FMEA manual introduces a 7-step systemic approach that views the resulting FMEA as a record of the technical analysis. While reviewing the 7 steps, you will discover that included within many of the steps are tools that we have been employing for robust FMEA development for years. These tools are now embedded into the 7-step methodology. In addition, the manual encourages organizations to develop foundation FMEAs upon which to build a robust design and process risk analysis process. Furthermore, the 7-step approach also includes some new content and a new approach to evaluating and managing recommended actions, among other changes. The 7-step approach is as follows. Step 1. Planning and preparation. The new manual includes valuable detailed information regarding topics that should be reviewed and considered early in project planning phase prior to any FMEA activities. The purpose of this discussion is to ensure that you achieve the best results and benefit from the FMEA. The planning stage generally includes determining the scope of the project, the type of FMEAs to be completed, concept, system, subsystem, component, etc., setting the boundaries of the FMEA analysis and defining the basis for the structural analysis step. The 5 Ts of FMEA development must also be taken into consideration during the planning and preparation step. The following is a list of the 5 Ts along with a brief description of each topic. FMEA, intent. Ensure that the team members are competent to participate in the FMEA based on their experience and role in the FMEA development process. More importantly, they should understand the purpose of the FMEA. FMEA timing. In order to gain the most benefit from the FMEA, it should be a before the event process and not an after the fact exercise. It is much easier to make changes to a design or process prior to design completion or process implementation. FMEA team. The FMEA team should include members from different disciplines who have the subject matter knowledge and experience to obtain the greatest benefit. The AIAG and VDA manual provides a great deal of information and insight regarding the team members and their various roles and responsibilities. FMEA task. The 7-step process outlined in the manual clearly identify the tasks and deliverables at each phase of the FMEA development. The team should also be prepared to share information with management at various times during the process. FMEA tools. There are many different software tools on the market that can be used for FMEA development. In some cases, organizations develop their own internal software. In addition, there is always the traditional form-based exercise utilizing the standard spreadsheet method. The manual provides an example of both a software and a spreadsheet developed FMEA. Step 2, Structure Analysis. During the structure analysis step in the FMEA process, the team should identify the boundaries of the design or process being analyzed and define the scope of the analysis to determine which systems, subsystems, and/or components will be part of the FMEA analysis. The interfaces and interaction of the items within scope must also be addressed. Tools that are useful in analyzing the structure, interactions, and scope of the FMEA analysis are the boundary or block diagram and the structure tree. Step 3, Function Analysis. The functions specified by the design functions are allocated to the system elements during this step in the process. The inputs, interfaces, and outputs of the function or system are also reviewed. The tools useful in this step of the process are the P-diagram and function tree. The internal and external customer requirements should be included. The team should also review the association of certain design features or requirements to the functional requirements. A correlation matrix or QFD level 2 are effective tools for application during this activity. Step 4, Failure Analysis. The product potential failure modes, effects, and possible causes are developed and reviewed during this step in the process. A failure mode can be defined as the method in which a product or process could fail to meet requirements or perform the desired function. The new standard also includes information describing the failure chain. The failure chain is best explained as the links between the failure mode, the resulting effects, and the initial causes of the failure. It is shown graphically below. The failure chain highlights the 3 aspects of failures that are examined in the FMEA exercise. Failure modes, effects, and causes can be viewed as links in a chain. To link the effect to the failure mode, you should ask yourself what happens if the failure mode occurs. In the same way, to link the cause to the failure mode, ask yourself why. Why is the failure occurring? These questions bind the links in the failure chain. Step 5, Risk Analysis. The risk analysis is the stage in the FMEA process where we evaluate the severity, occurrence, and detection rankings in order to generate and prioritize recommended actions to mitigate risk. The risk analysis objects include but are not limited to the following: evaluating the rating of each failure chain for severity, occurrence, and detection rankings. Application of prevention controls to address potential causes. Application of detection controls to address the potential causes and failure modes. Evaluation of the action priority. Sometimes initiate collaboration with suppliers and customers. Provide the foundation for the optimization step. Always remember this: we can take action to prevent or eliminate the causes of failure, but we can only detect the actual failure mode. We cannot detect a cause, and the only way to prevent the failure is to prevent the cause of the failure. In other words, prevent the cause and/or detect the failure before it leaves your facility or reaches your customer. AP not RPN. One of the major changes with the new AIAG VDA FMEA manual is that the risk priority number or RPN has been eliminated. It has been replaced by the AP or action priority process, where RPN considers severity, occurrence, and detection rankings equally SOD, which correlates to the new AP system considers first the severity then the occurrence values and so on. The AP tables included in the new manual take all 1000 variations of S, O and D into consideration. The tables assign one of 3 suggested rankings for each action based upon the S, O and D values. The AP rankings are as follows. H. Priority high, the highest priority for the team's review and action. The FMEA team needs to identify an appropriate action or improve the prevention or detection controls. M. Priority medium, the second highest priority for the team's review and assigning of action. The FMEA team should identify an appropriate action or improve the prevention or detection controls. L. Priority low, low priority for consideration and action. The FMEA team could improve upon the prevention and detection rankings, although the team is not prevented from taking action at any level. Notice the key terms used in each of the designations. The could, should, and needs descriptive terms clearly communicate the urgency for the team to address the associated design or process risk. Step 6, Optimization. While the risk analysis evaluated the design or process risk and assigned a ranking for consideration of action, the optimization step is where the FMEA team determines what action to take and evaluates the action's effectiveness. In the new manual, the actions have been divided into separate categories of prevention and detection. Although many practitioners have been separating the type of action for many years, prior to the publishing of this manual, the main objectives of the optimization step in the 7-step process are as follows. Identify all appropriate actions to address and mitigate risk in the design or process. Assign an owner or responsibility for completing the action along with an expected completion date. Experience teaches us that an action without an owner or a due date are orphans and are frequently forgotten and never completed. Documenting the actions taken and ranking of their effectiveness in reducing risk. Serve as an agent for improvements to the design or process as a result of the actions. Encourage collaboration between departments or various disciplines within the organization and at times with suppliers or customers. During this step of the process, the FMEA team shall review the results of the actions and rescore the occurrence or detection rankings accordingly. The optimization step is most effective when the intent of the action is to: first, eliminate a failure effect. Second, reduce occurrence of the failure. Third, increase the detection of the failure. The severity can be changed, but experience has proven that it is rare and typically requires a major design or process change or change in the design or process requirements. Step 7, Results documentation. Following through on the 7th step in the AIAG VDA FMEA process should improve an organization's documentation of the FMEA activity and communication of the results. At the heart of the results, the documentation step is the FMEA report. The report is not intended to be a substitute for any management reviews or communications with the customer or supplier. The FMEA report is primarily a summary of the findings, a review of the risk analysis and confirmation that the actions have been completed. There is no template or standard format for the FMEA report. The report's content and structure can vary from company to company. The FMEA report generally includes a comparative statement of FMEA analysis results to the team's original goals. This may include the 5 T's mentioned previously: intent, timing, team, task, and tool. A summary of the scope of the analysis along with identification of new content. A brief explanation of the method used to develop the design or process functions. Summary of the high-risk failures identified and the actions developed to mitigate the risk. A plan for completion of any ongoing or future design or process improvement actions. In short, The results documentation step should help improve your FMEA process by communicating the results and conclusions of the FMEA analysis, documenting actions taken and their effectiveness, and providing a record of the risk analysis and subsequent risk reduction in the design or process. FMEA MSR, Monitoring and System Response. An additional FMEA methodology has also been included in the AIAG VDA manual. The FMEA MSR is used to evaluate a system's ability to maintain a safe state of operation and/or compliance to applicable regulatory requirements during customer operation. The focus of the FMEA MSR is the monitoring system's ability to identify faults/failures and the effectiveness of the system's response. Often used in conjunction with FMEA, although not intended for use with everyone. The methodology is intended for evaluation of systems that perform active or passive monitoring and response functions. Can be used to further evaluate risks that may be ranked as high or are safety/regulatory related. Implementation of this FMEA methodology may also be useful to an organization's adherence to the ISO 26262 functional safety standard. The 7-step process of the FMEA MSR is very much the same as FMEA, with the exception of Step 4, Failure Analysis, and Step 5, Risk Analysis, Methodologies. MSR, Failure Analysis. Previously we reviewed the failure chain for FMEA, where we examined the links between the failure cause, failure mode, and the failure effect. During the FMEA MSR we take a look at how the system is monitoring proper functionality, the system's ability to detect a failure during operation, and the systemic action to mitigate or reduce the severity of the effect of the failure, as shown in the model below. MSR, Risk Analysis. Within a standard FMEA, risk analysis is performed through evaluation of the severity, occurrence, and detection rankings. The FMEA MSR approaches risk analysis in a different way. The FMEA MSR methodology utilizes SFM, or severity, frequency, and monitoring to estimate the risk of failure and prioritize the need for further action. Severity: how bad is the failure effect if the fault were to occur? Frequency: how often is the cause/fault likely to occur during the service life of the vehicle? Monitoring: evaluation of the ability to detect a fault/failure during customer operation and the application of the fault reaction to mitigate risk and maintain a safe/compliant state of operation. The suggested worksheet format for the FMEA MSR has been adjusted to align with the SFM method. The methodology for use of the action priority tables is basically the same. Although, FMEA MSR action priority tables themselves are different than the one for DFMEAs. In conclusion, the new AIAG and VDA FMEA methodology has a lot of new content and some different ways to approach FMEA activities. The new methodology will be of great value to companies desiring to become suppliers of German automakers, and the use of a common format and methodology will improve communication between existing suppliers and manufacturers. One example of the linkage of the FMEA MSR methodology to the ISO 26262 requirements is illustrated in the following example. Consider the car you drive every day and then consider how many electronic systems are in place to keep you and your passengers safe. Whether it is the electronic shifting or braking system, active lane assist or adaptive cruise control, all these systems must operate at peak performance or have an appropriate warning or mitigation if a fault is detected. We are gradually becoming used to these systems in vehicles and tend to rely on them. Whether your organization is planning on implementing the new AIAG VDA FMEA methodology or FMEA MSR, these tools can be extremely effective when utilized to their fullest extent. While adapting your organization's FMEA process to the new standard may seem quite daunting, there are many advantages and help.